Redundant connection. In this problem, a tree is an undirected graph that is connected and has no cycles. You are given a graph that started as a tree with n nodes labeled from 1 to n with one additional edge added. The added edge has two different vertices from 1 to n and was not an edge that already existed. The graph is represented as an array edges of length n where edges I value is equals to ai and bi. Indicates that there is an edge between uh, nodes a, I, and bi in the graph. Return an edge that should be removed so that the graph is a tree of n nodes. If there are multiple answers, return the answer that occurs last in the input. So I'll copy and paste this so that I can keep my mind, so that we can keep our mind to it. That's what we need to return. So example one, visualize the image. We can't tell exactly which one here is the edge simply by looking at this. So that's how we go to the edges. So edge one is 1 to 2, 1 to 2. Edge two is 1 to 3, 1 to 3. Edge three is 2 to 3, 2 to 3. We already had these two numbers. That's how I put 2 to 3. There should be only one path in edges in our three without being called onto again. So in this example, so in this example, example two, visualized. This one also we can't tell which one is the edge. So let's go to our edge list. So let's add 1 to 2, 1 to 2, and then 2 to 3, 2 to 3, 3 to 4, 3 to 4, and then 1 to 4. These two have already been involved, so there is a cycle here. But let's go ahead and keep going. 1, 2, 3, 1 to 5, and that's how I put it here. 1, 2, 3, 1, 1 and 4. That's how those are the edges that need to be taken out. The edge that needs to be taken out, not the edges. So this is a union find problem. So let's make n equals to the length of edges. Let's make hold on parent to be equals to list of range n plus 1, and then let's make rank to be equals to, we can put any value, basically any value. Let's just put 1 or 0 because it's going to be for every single value. It will make it even. So times n plus 1. So every value in the index in the list will be 0 so far. For our list to whole parent of each edge. And then let's make hold on, list to hold on, list to rank slash tweet to compare which needs to be a parent of which. So now let's go to our find function. Find function to see function to find parent. So let's call it def.find parent and make a node, and then go ahead and check if parent node if the node's parent is not equals to the node itself. Oops, not equals to node itself. Let's make it let's make parent the node's parent to be equals to let's call it on it itself. So that would be path for the parent, and then parent the node of it. Let's update it. Update parent to root. So now let's return parent the parent node the parent of the node. So now let's go ahead and move to union. Union function to to unite slash union enter 3. So let's make it, so let's check. So def dot union, and then let's put parent into it, and rank, because we're going to need that too, and node 1 and node 2. That will be both nodes. So so now let's make root 1 to be equals to root 1 will be equals to the find. Let's call the find. Let's look for, that means we're looking for the parent, and then make parent and then node 1. Root 2 will be to look for the parent of node 2. Oops, find parent on node 2. So now we're going to check if we detect a cycle, it's false. It's false. So we do that by if root 1 is equals to root 2, return false. And then let's move by, so let's check again. So if, let's compare the rank of root 1 and 2 to see which will be parent of which. So let's check. So if the rank of root 1 is greater than rank of root 2, the parent of root 2 will be equals to root 1. If rank of root 1 is less than the rank of root 2, we make the parent of root, wait, this time is it 1 will be equals to root 2. Else let's make the parent of root 1 to be root 2 to be equals to root 1. Then let's take the rank of root 1 and then add 1 to it, so plus 1. And then move out, let's make return equals to 1. Hold on, yes. Wait, no, false. I mean true. So once we make it out of this, let's make our loop for A, B, and edges. If we don't have, if it's false, if it's a cycle, so union, not union, so it has to be this. If not union, hold on, we forgot to put parent rank A and B, and hold on, return A, B. Let's see if there's anything syntax errors that need to be taken care of. Looks good. There might be a syntax errors. Node 1, oops, 2 node 1s. This happened last time I did this. And it's been accepted. So our time complexity. Our time and space complexities are both over n plus 1. I mean over n. Space complexity are both over n. So we store values depending on how much we have inside, and our time complexity for going through the edges will also be how much values we have inside. That's why we have that. So let's submit to see if it's going to pass all cases. And it's been able to pass all cases, and that's it for this problem.